In this class, now I am going to explain you properties of triangles from trigonometry. We have one more name also there for this properties of triangles, that is solution to a triangle. So to finish this chapter, I take 3 classes. Among that 3 classes, this is first class. So in this first class from properties of triangles, now I would like to explain you concept related to sine rule, cosine rule, tangent rule and projection rules, and also half angles of sine, cosine, tan and cot. And also I explain you concept related to area of a triangle. So before going to this class, now I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Now let us go to the class. So first let me explain you sine rule. In triangle ABC, see here, draw one triangle, name this triangle as ABC. So as you know, the side which is opposite to vertex A, that is BC, whose length is represented by small a. So AC length is represented by small b because opposite to vertex B. So AB length is denoted by small c, opposite to vertex C, where small a, small b, small c represents lengths of sides of this ABC triangle. So in this triangle ABC, A by sine A is equal to B by sine B, which is equal to C by sine C, now which is equal to 2R, is known as sine rule. Okay, see here, you know what are meant by ABC. Now we are capital A, capital B, capital C represents interior angles of this triangle ABC, and where capital R represents radius of circumcircle of this triangle. This is what? That is circumcircle. Okay, so which is passing through 3 vertices of triangle ABC. So whose radius is denoted by capital R. Here you may get center of the circumcircle over here. Now this, okay, it is denoted by the letter S. Now SA, SB, SC. These 3 represents radius SA, SB, SC, which is equal to capital R. Okay, right. So even if you equate first and last, now A also can be written as 2R sine A. Similarly, B can be written as, when you transfer 2B to the right side, 2R sine B. Now C is equal to 2R sine C. So this is sine rule. Okay, it is a very important rule. So in this properties of triangles, so with the help of this sine rule, we are going to attempt many more applications. So right here, I hope you have understood this statement of the sine rule. A by sine A, which is equal to B by sine B, which is equal to C by sine C, equal to 2R, where small a, small b, small c represents lengths of sides of triangle ABC, and where capital A, capital B, capital C represents interior angles of the triangle ABC, and a capital R represents a radius of circumcircle of this triangle ABC. Okay, now let us go to whose proof. Okay, now I explain you proof of the sine rule. Okay, so by 3 cases I am going to explain you this proof. Now let us see that. See, in the first case, that is case 1, consider, okay, A is an acute angle. Okay, angle A is an acute. Angle A is an acute. See, ABC is a triangle in which angle A we have taken as acute. Now draw the circumcircle. How do we get? We get the circumcircle like this. Where do we get whose center? We may get over here. Let it be S. Circumcenter. Okay. Now here I am going to prove A by sin A is equal to 2R from this diagram. How? Observe me. See, to prove this, now I would like to draw a diameter of this circle. That is BD. Okay. Now you know this is one semicircle because, as I said, BD is a diameter. If it is diameter, you know this angle will be how much? So here, okay, I took BD diameter. I am connecting B and D and C. Now here one BCD triangle is formed. Okay, where angle BCD will be 90 degrees. How it will be 90 means, see here, this is one semicircle. You know, the semicircle will make, see here, for this semicircle, so BD is arc. Now this arc will make how much angle at here? 90, because as per the degree measure theorem, this arc is making 180 degrees angle at the center by the degree measure theorem, which you have learnt in the circles, plane geometry circles chapter. As per that theorem, so okay, this arc makes 180 degrees at the center. Then this angle will be half of this 180. Okay, so as per the degree measure theorem, so this angle is how much? Half of this. It is 180. Hence it will be 90 degrees. Okay, fine. Now go to here. Go to here. Okay, define sin D. From triangle BCD, what I am doing? I am defining sin ratio at angle D. Sin D, which is equal to, opposite is BC and hypotenuse is BD. Right, students? So you know, hereafter, you know, length of BC is how much? We have taken small a, and BD means diameter, no? As you know, diameter length will be how much? Twice of the radius. Radius of the circumcircle is capital R. Then BD length will be how much? 2R. Okay? Right. So observe this figure carefully. So now take this arc. Okay. So this is one segment and this is one more segment of this circle. Now this arc is making two angles on the other segment. What are that? D and A. So this is the angle which is formed by same arc. See here. And this is the angle which is formed by same arc. See here. This arc is making same angles on the other segment. You know. Okay. It is one application of degree measure theorem in circles chapter, plane geometry circles. Angle formed on the same segment of a circle are equal. Okay, so as per that okay application, so you can say that these two angles are equal. Angles formed by the same arc on the same segment are always equal. Okay, so as per that, so you can say that angle D is equal to angle A. Now replace this D by A in the next step. Replace D by A. So what do you get? Sin A is equal to BC. BC length is small a and BD length 2R. Okay. Now take cross multiplication so that you will get 2R sin A. Now you got no 2R sin A. When you bring sin A to the left side, A by sin A equal to 2R you got. Okay students. So here we have got A by sin A equal to 2R. Similarly, if you would like to prove B by sin B equal to 2R, you have to replace A by B and follow the same procedure so that you will get B by sin B equal to 2R. Similarly, if you would like to prove C by sin C equal to 2R, replace this A by C and follow the same procedure so that you will get C by sin C equal to 2R. Okay? I hope you have understood this A by sin A equal to 2R. Okay? When we have got A by sin A equal to 2R, when A is an acute angle. But every time angle A need not be an acute, no? It may be right angle triangle. It may be an obtuse angle. Okay now. So that if it is acute, we have proved this. A by sin A equal to 2R. Suppose if it is right angle, then can we get A by sin A equal to 2R? Yes. If A is acute, if A is right angle, if A is obtuse also, we will get A by sin A equal to 2R. Now, I will show you. Okay, how this A by sin A equal to 2R when angle A is a right angle. So, see students, now let us go to the case 2. Case 2. Now see students, in the case 2, I am considering angle A is a right angle. That is angle A equal to 90 degrees. Now see students, okay, now this is ABC. Okay, this BC side is passing through center of the circle. Okay, in such case only here we get 90 degrees angle, because here this is one semicircle. When you consider BC is a diameter, this arc makes 180 degrees angle at the center, and this angle will be how much? Half of this. Okay, now angle BAC is a right angle triangle, because we found that angle A is 90 degrees, hence BAC is a right angle triangle. Okay, fine. Now BC is called what? Diameter of this circle, no? Diameter of this circumcircle, as we know. So BC length is equal to 2R, because 2R is the circumdiameter, double of the radius of the circumcircle, that is 2R. So what do you say 2R? Circumdiameter. Okay, but as you know, so the length of BC side of triangle ABC is denoted by small a. Hence what you people can comment, A is equal to 2R. A is equal to 2R. Now A is equal to 2R into 1 you can write in the next step. Now A equal to 2R into 1 also can be written as sin 90 degrees. You know, sin 90 is 1, no? Now A is equal to 2R into 90 degrees. Replace 90 degrees by A. Now you got A by, A is equal to 2R sin, no? And now transfer sin A to the left side, so that you will get A by sin A equal to 2R. Okay, even A by sin A equal to 2R also we have proved when angle A is a right angle. Okay, even angle A may be obtuse also, no? So if it is obtuse, then okay, let us go to proof. A by sin A equal to 2R. That is case 3. Angle A is obtuse. Obtuse means you know that angle is more than 90 degrees and less than 180 degrees. So in that case, here we would have to take the diagram like this. See here. This is BC and here it is A. Now connect, okay, BA and CA. Now you may get center of the circle over here. Okay, students. Now here, okay, to prove this A by sin A equal to 2R, I am taking two constructions. See those two constructions. Now I am taking a diameter CD. CD is one diameter. Okay, and connect to B and D. Okay, now you know this is one semicircle which makes 180 degrees at the center, and this angle is half of this 180. Now CD, you know, it is diameter, you know, circumdiameter is equal to 2R. Okay, students. So here define sin D. This is small a. Am I right? Okay, now DBC is a right angle triangle in which what I am doing? I am defining sin ratio at this angle D. If you define, what do you get? Sin D is equal to opposite with respect to this angle, opposite is BC, that is small a, by hypotenuse value 2R. Okay, I hope you have understood how I have written this step. Now hereafter, see, okay, observe this A, B, D, C. So this is one quadrilateral. Am I right? Because having 4 line segments AB, DB, DC, CA. A, B, D, C. A, B, D, C, A. So this is a quadrilateral. What kind of quadrilateral is this? A cyclic quadrilateral. Because the circle is passing through 4 vertices of this quadrilateral. Hence it is a cyclic quadrilateral. As you know, in the cyclic quadrilateral, sum of the opposite angles is supplementary. Means angle D plus angle A is equal to 180 degrees. Now angle D is equal to 180 degrees minus angle A. Now replace this D by 180 minus A. So that what do you get, students, here? 180 minus A is equal to A by 2R. Now you know sin 180 minus A is equal to sin A only. So which is equal to A by 2R. So now A can be written as, when you transfer this one left side, A equal to 2R sin A, or you can also write A by sin A is equal to 2R. Okay, students. So similarly, if you replace this A by B, you will get B by sin B equal to R. If you replace A by C, you will get C by sin C equal to 2R. Okay. So here I proved the sine rule. When angle A is an acute, angle A is right angle, angle A is obtuse. So that I got A by sin A equal to 2R in all these 3 cases. So if you would like to prove B by sin B is equal to C by sin C equal to 2R also, you have to replace A by B, you have to replace A by C, so that you will get B by sin B equal to C by sin C equal to 2R. Okay. So This is the required proof of sine rule. Okay. Now let us go to the cosine rule. Students, see cosine rules. In a triangle ABC, so BC length is denoted by small a, AC length is small b, AB length is small c. So you know these three are interior angles of triangle ABC. Now see the cosine rules. A square is equal to B square plus C square minus 2BC cos A. So now B square is equal to C square plus A square minus 2CA cos B. Now C square is equal to A square plus B square minus 2AB cos C. So these three are known as cosine rules. Okay. Now I explain you. So this first rule, A square is equal to B square plus C square minus 2BC cos A. Similarly, you can prove these two. Okay, students. Even to prove this first one, I would like to consider angle A is acute, angle A is right angle, angle A is obtuse, same like previous one. Okay, right. Now let us see this first cosine rule proof. To prove it, students, observe me. So now I would like to take angle A over here, B here, C here. Now angle A is an acute. So you know this BC length is denoted by small b. Small a, because opposite to vertex A, no, small a. Now AC length small b, AB length small c. Okay. So hereafter, students, draw an altitude from B to AC, which meets a point on AC, that is a D. Okay, students, I took one construction, that is BD is perpendicular to AC. Okay, right. Hereafter, so take this triangle BDC. Take BDC triangle and apply the Pythagoras theorem to BDC triangle, in which hypotenuse is BC. Okay. Now BC square is equal to BD square plus DC square. Okay. Now BC is nothing but small a, no? Now replace BC by small a square plus BD. So in place of BD, students, so here take this triangle, Now this is also right angle triangle, in which apply the Pythagoras theorem, so that you will get AB square, which is equal to AD square plus BD square. Now make BD as subject, so that here you will get AB square minus AD square, which is equal to BD square. So in place of this BD square, so write this, so that here you will get AB square minus AD square plus DC square. Okay, students, and hereafter, okay, see, I hope you have understood this Pythagoras theorem. Okay, it is obtained by applying Pythagoras theorem to this right angle triangle. Why? Because here I require BD square. Okay, to replace BD square by this, so I considered this right angle triangle. Okay, in the next step, so in this AB length, you know, small c, right? This AB as small c, so that here you will get c square minus, so write this AD square as it is, AD square as it is, but in the place of DC, In the place of DC, you can write AC minus AD whole square. Okay, students. This is DC. DC is nothing but what in this figure? AB minus AD. AC minus AD. That is equal to DC. I replaced DC by AC minus AD whole square. Now go for simplification. A square is equal to C square minus AD square. It is looking like A minus B whole square. Now expand it by the A minus B whole square identity. Here AC square plus AD square minus 2AC into AD. Now see students, it is minus AD square plus AD square. Both are cancelled. Now here A square which is equal to C square plus here AC students. So what is the length of AC in that figure? So that is small b. Now replace AC by b. So that here you will get plus b square minus 2 into AC. AC is how much? Small b. Small b into AD. Okay students. So see students, in the place of AD what I am going to write, observe me carefully. So here go to this ADB triangle. ADB triangle in which define cos A. Now cos A is equal to how much? Adjacent by hypotenuse. Adjacent is AD and hypotenuse is small c. So now AD is equal to C into cos A. C into cos A. Okay students. So 2 into AC. Okay, AC value B and AD value C into cos A. Okay. Now we have got now our required cosine rule. A square is equal to C square plus B square minus 2BC cos A. Okay. Right. And this is the proof of cosine rule when angle A is an acute. Okay. Every time angle A need not be an acute, no. It may be right angle, it may be obtuse. If it is right angle, how do we get? Okay, I will show you. So before that, so even this one also can be written like this students. So cos A is equal to B square plus C square minus A square by 2BC also you will get. Okay, transfer this one to the left side and send A square to the right side and simplify so that you will get cos A is equal to B square plus C square minus A square by 2BC. Okay, right. Now let us go to the case 2. In the case 2, okay, angle A is equal to 90 degrees. So if angle A is 90 degrees, so we would have to take the right angle triangle like this. Okay, now BC length will be how much? Small a. AC length will be how much? Small b. AB length will be how much? Small c. Okay students, now apply the Pythagoras theorem so that you will get A square is equal to B square plus C square. Okay Nama? Right. So here, shall I write minus 2BC into cos 90 degrees? Yes, substitute you can write. Because cos 90 degrees is equal to 0. So 0 into something, 0. So that actually by this diagram, we get A square is equal to B square plus C square. But wantedly I wrote minus 2BC cos 90. Because you can write cos 90 0, 0 into something 0. Now here A square plus B square plus C square minus 2BC. So in that diagram, shall I replace 90 degrees is equal to angle A? Yes, because in the beginning we have considered ABC is a right angle triangle in which angle A is equal to 90 degrees. Hence, as per the given data, so you can replace 90 degrees by A. Okay? So now observe this. what we require we have got. Okay, so this is a cosine rule. When angle A is right angle, even it is also can be written as cos A is equal to B square plus C square minus A square by 2BC. So now if it is obtuse, how do you prove? If angle A is obtuse angle, now tell me how do we prove it? So in the case of obtuse angle, how do you take whose diagram? See, you have to take right angle like this. Sorry, obtuse angle more than 90. Now you can take B here, C here. So that this AB length can be written as small c and AC length can be written as small b, BC length can be written as small a. Hereafter, see students, what I am doing, observe me. So this BA, now I would like to extend. BA I have extended. So on this extension, drop a perpendicular from C, which meets this extension part at somewhere, let it be D. Now this is 90 degrees. Okay. Now from triangle CDB, okay, apply Pythagoras theorem. So hypotenuse BC square, which is equal to CD square plus DB square. Now BC is how much, amma? Small a. Small a square is equal to CD. CD length. Do you know CD length? Don't know. So from a CDA triangle, from triangle CDA, apply Pythagoras theorem, so that you will get AC square is equal to CD square plus DA square. Okay students, now CD square can be written as AC square minus DA square. Okay, so in this CD square, what you substitute? AC square minus DA square. Hereafter DB. DB means, see in this figure, that can be expressed as DA plus AB. DA plus AB. Now whole square. Now let us go to simplify this. Now AC square minus DA square. It is looking like A plus B whole square, no? Now A plus B whole square formula, A square plus B square plus 2AB. 2DA into AB. Okay students. So observe this step. So plus minus DA square plus DA square cancel. So now here A square plus AC. AC means here whose length is denoted by small b. B square plus here AB. AB length is taken as C, no? No, right there, C square plus 2DA. DA length don't know, but AB length is C. So 2C into DA you got. DA, or you can write as AD. So students, you know, this is interior angle, that is A. So when you come here, how much is this? Both are forming linear pair. So this is A, obviously this will be 180 minus A. How much is this? In ADC triangle, this angle will be 180, because this angle and this angle, whose sum becomes 180. Sum of two adjacent angles is 180. Then that pair is known as linear pair, no? If it is A, then this will be 180 minus A. Now add both angles, minus A plus A cancel, 180 you are getting, no? And if it is A, then this will be 180 minus A. Okay. Now with respect to this 180 minus A, in this right angle triangle ADC, define cos 180 minus A. Cos 180 minus A is equal to adjacent by hypotenuse. Adjacent is AD, hypotenuse is AC. Now cos 180 minus A is equal to, you know, minus cos A, which is equal to AD by AC. Okay, right. Now see that, students, observe this step. AC length is how much, amma? AC. small b. Now write here small b and bring it to the left side, so that you will get AD is equal to minus b cos A. AD is equal to how much? Minus b cos A. Now in place of this, write minus b cos A. Now here in place of dA, if you write this minus b cos A, what do you get here? A square is equal to b square plus c square plus 2c into dA. dA is equal to minus b cos A. Minus b cos A. Now simplify. A square, which is equal to b square plus c square plus into minus minus 2bc cos A. This is our required cosine rule. A square is equal to b square plus c square minus 2bc cos A. Okay, I hope you have understood this proof also. So if you would like to prove that b square equal to something, c square equal to something, two more formulas are there now in the cosine rule. So you would have to replace a by b, so that you will get b square is equal to c square plus a square, okay, minus 2ca cos b. So suppose if you replace angle a by c, you will get c square is equal to a square plus b square minus 2ab cos c. Okay na students, even these formulas also can be written like this also. Three formulas. Cos A is equal to, by this what do you write amma? B square plus c square minus a square by 2bc, and cos B, which is equal to c square plus a square minus b square by 2ca. Similarly, cos C is equal to a square plus b square minus c square by 2ab. Okay students, so these are cosine rules. Okay, now let us go to the tangent rules. Now see, here also we have three rules. See these three rules. Tan of b minus c by 2 can be written as b minus c by b plus c into cot a by 2. Even second one, tan of c minus a by 2, which is equal to c minus a by c plus a into cot b by 2. And the next, tan of a minus b by 2, which is equal to a minus b by a plus b cot c by 2. So these are tangent rules. So now I explain you any one of these three proof. Okay. Now let us see the proof of the first one. Okay. So now to prove this tangent rule, so okay, I would like to consider RHS. I take RHS, then I prove LHS. Okay. Otherwise, so okay, you can do like this, proof of this. And now simplify this, b minus c by b plus c. B minus c by b plus c. So for this I need to use sine rule. You know what is sine rule? So already we proved. Then we got a equal to 2r sine a, b equal to 2r sine b, c equal to 2r sine c. No? Use that. Now b is equal to 2r sine b. Now c is equal to 2r sine c whole by 2r sine b plus 2r sine c. Now let us take 2r common from the numerator and 2r common from the denominator, so that you can cancel. Okay, so after cancelling 2r taken from numerator, taken from denominator, and go for cancellation. After that, what is left here? Sin b minus sin c whole by sin b plus sin c. Okay students, right. Hereafter, so for this numerator and denominator, I am going to apply transformation formulas. Okay, so in the transformation of trigonometry, there we learnt 4 rules, no? Sin C plus sin D, sin C minus sin D, cos C plus cos D, cos C minus cos D. So here, see how the numerator and the denominator. So for the numerator, apply the transformation of trigonometry formula, sin C minus sin D, which is equal to 2 cos C plus D by 2 and sin C minus D by 2 whole by sin C plus sin D, 2 sin B plus C by 2, yes, cos B minus C by 2. Okay, right? Now, okay, these two get cancelled. Okay, Amma. Now, you know what are ABCs here? Angles in a triangle ABC, no? And as we know, whose sum is equal to A plus B plus C equal to 180 degrees. Now here, B plus C is equal to 180 minus A. If you divide both sides by 2, so what do you get? 90 minus A by 2. And here, okay students, now here, see, sin B minus C by 2 by cos B minus C by 2. Sin by cos, tan. Tan B minus C by 2 you will get. So here, in the denominator sin B plus C by 2 is there. Now I am bringing this cos B plus C by 2 from numerator to the denominator. So that when you bring this one to the right down, it becomes sin by cos. Okay. Now sin by cos becomes tan. Tan. Now B plus C by 2 you will get. Actually what we are simplifying? So this value B minus C by B plus C is there left side. B minus C by B plus C. So students, see here, tan of B minus C by 2 by tan of B plus C by 2. B plus C by 2 is nothing but what here? 90 minus A by 2. Okay. So as you know, tan 90 minus C by 2 is A by 2 equal to cot A by 2. Tan of B minus C by 2 whole by tan 90 minus theta is equal to cot theta. So cot A by 2. Okay students. So B minus C by 2 equal to B plus C. What you got? Tan of B minus C by 2 by cot A by 2. Now bring this cot A by 2 to the left side. So that what do you get? What do you get? See here, tan of B minus C by 2. When you bring that one to the left side, so that you will get B minus C by B plus C into cot A by 2. Okay. So this is tangent rule. In a triangle ABC, tan of B minus C by 2 equal to how much? B minus C by B plus C into cot A by 2. Similarly, you can prove remaining two tangent rules. Okay, na? Right. Now let us go to the projection rules. See the projection rules. Students, see here we have three projection rules in a triangle ABC. In a triangle ABC, small a is equal to B into cos C plus C into cos B, and small b is equal to A into cos A plus B into, A into cos here C, and here C into cos A. Now small c is equal to A into cos B plus here B into cos A. Okay students, see here small a, here BC combination, B and cosine C, and small c cosine B. Here small a, small b, small c represents what? Lengths of sides of triangle ABC, no? See here, small b is equal to, when you write here b, now RHS you will get AC combination. So here small c. So which combination do you get RHS? A, B. Here A into cosine B plus B into cosine A. Small a represents side, angle B represents angle. Here B represents angle in a triangle ABC. Small a, side length. So small b, side length, angle A represents angle in a triangle. I hope you have understood. These three are known as projection rules. When you want to write a projection rule for small a, what do you get RHS? BC combination, B cos C plus C cos B. And small b equal to A cos C plus C cos A. Small c equal to A cos B plus B cos A. Okay, now students. So first one I prove. Okay. Even you can prove this projection rules by two ways. So I explain you the two ways. So one can be obtained by this diagram ABC. Okay, students. So to prove this, now I would like to drop a perpendicular on BC. That is small a. BC length is small a. I took an altitude AD. Okay. Now go here, go here. Okay. Define cos B here, define cos C there. You know this length is small c, this length is small b. Okay, students. Now take this right angle triangle and define cos B. Cos B is equal to adjacent by hypotenuse. Adjacent is BD and hypotenuse is small c. Now BD is equal to C into cos B. C into cos B. Similarly, go to this right angle triangle and define cos C. Cos C is equal to DC by AC, that is B. Now DC is equal to B into cos C. Okay, students. So right. Now when you here BC, in that figure BC can be written as BD plus DC. You know BC length is how much? Small a. BD length is C into cos B plus DC is how much? B into cos C. Okay, students. Now we have got this. Okay. We have proved this first projection rule by this triangle ABC. To prove it, I took an altitude and I went to define cos B and cos C from these two right angle triangles, so that I got this. A is equal to B cos C plus C cos B. Similarly, even you can also prove same theorem, okay, by cosine rules. Take RHS. What is there in the RHS part? B into cos C plus C into cos B. Now which is equal to B. So in the place of cos C, write the cosine rule. What is that? B square plus C square minus 2BC by cos C is equal to, students here, A square, no? A square by 2BC plus C into cos B. A square plus C square minus B square by 2AC. Now let us simplify. BB gone, CC gone. Now what is left here? Okay, students, CC gone. Go for this simplification. B square plus C square minus 2BC. Correct only here we have. Here we wrote wrong here. So cos C is equal to here A square plus B square combination will come. A square plus B square here minus C square by 2AB. Now this B gone. So go here. Cos B. A square plus C square minus B square by 2AC. CC gone. Now here 2A left, here 2A left. LCM is 2A. Now here it is A square plus B square minus C square plus A square plus C square minus B square. Now this plus B square minus B square gone. So minus C square plus C square gone. Now what is left here? A square plus A square. That is equal to 2A square. That can be written as 2A into A whole by 2A. Now 2a cancel. Small a left. So this is LHS part. Now we got LHS equal to RHS since it is proved. Okay. So two ways you can prove it. So one projection rule I proved here, and the remaining two projection rules you can try. Now let us go to define this sine, cosine, tan, cot at half angles. Okay. Next, what we people are going to do? We are going to define that sine, cosine, tan, cot at half angles. Okay. So half angle of sine, that is sine A by 2, sine B by 2, sine C by 2. Because we are discussing these half angles in triangle ABC. Okay. So mostly when 90% of the chapter we name of the triangle as ABC only, and whose sides length will be measured in terms of small a, small b, small c only. Okay. Unless they give conditions in the application. Okay. Alright. So now let us go to define half angle of sine. That is sine A by 2. Because A is one of the interior angle of a triangle ABC. And sine B by 2, sine C by 2. Okay students. Now I am going to write formulas for this 3. Sine A by 2, sine B by 2, sine C by 2. So to prove this, okay, sine A by 2, I would like to take this relation 1 minus cos A, which you learnt in the submultiples of trigonometry. So 1 minus cos A can be written as 2 sine square A by 2. Am I right? 2 sine square A by 2. Now take this, see, in the next step, okay, what do? Bring this 2 to the left side so that you will get sine square A by 2 is equal to 1 by 2 of 1 minus cos A. You know students, 1 by 2. So 1 minus, in the place of cos A, write that cosine rule which we have proved now. Okay, what you got cos A? Cos A students. So b square plus c square minus a square by 2bc. Now go for simplification. When you simplify, what do you get? Are you following me? What we are doing? We are defining sine of a by 2. Okay, that is called half angle of sine. For that, what did I do? I took this 1 minus cos A equal to 2 sine square A by 2 formula. Okay, you know this relation which we have learnt in the submultiples of trigonometry. So by that, so here sine square A by 2 equal to 1 minus, see, when you bring this 2 to the left side, you get this step. So in the next step, in the place of cos A, I wrote cosine rule of A. So now let us go to simplify this. If you simplify, what do you get? Yes, left side, what is there? Sine square A by 2. Now which is equal to, take cross multiplication. So what is the LCM here? 1 by 2. LCM is 2bc. Here nothing is there, means 1. 1 no 2bc. LCM will be 2bc. Now take cross multiplication. 2bc. Now open this bracket. So students, if you open here, minus b square minus c square plus a square you will get. So in the next step, here 2 2s are 4. Okay, the denominator plus 4bc you will get. Now observe this. This first a square I would like to write as it is, but from these three terms I would like to take minus common. When you take minus common here, you will get b square plus c square minus 2bc. So in the next step, a square minus b square plus c square minus 2bc can be written as b minus c whole square. Okay, identity by 4bc. Now it is looking like a square minus b square, no? A square minus b square can be written as a plus b into a minus b. A plus b means a, plus b means b minus c you will get. A minus b, a. Now minus of this, signs will change. Minus b plus c whole by 4bc you will get. Okay? You know, students, as per the Iran's So S is called what? Half of the perimeter of a triangle. That is called semi-perimeter. Okay. So you know here A plus B minus C we require. So take this S to the left, 2 to the left side, so that you will get 2S equal to A plus B plus C. Now here add plus C and minus C. So that here what do you get? Students, now sin square A by 2 is equal to, so here we got this much now. In the next step here, I would like to write A plus B plus C minus 2C. Can we write this one? Here I added plus C, minus C. Minus C minus C became minus 2C. Here A plus B plus C you got. If you take the difference of these two, again you will get this back step only. Similarly here also. A plus B plus C minus 2B. Because B minus 2B minus B you will get. Why I wrote like this means you will come to know in the next step. By 4BC. Okay students, in the next step A plus B plus C is nothing but 2S. Okay, write A plus B plus C is equal to 2S in this. So that you will get 2S minus 2C and here 2S minus 2B whole by 4BC. Now take 2 common from here, 2 common from here and cancel with the denominator. So that what do you get here? S minus C into S minus B by BC. Okay students, where this 4 has gone? I took 2 common from the numerator, 2 common from here. 2 to the 4. 4 I cancel with denominator. Now transfer square to the right side. Transfer the square to the right side so that you get sin A by 2 is equal to square root of S minus B into S minus C by BC. This is sin A by 2. I hope you have understood this proof, sin A by 2. Now can we able to write sin B by 2, sin C by 2? Now write. Similarly, if you follow the same rule, same procedure, you will get sin B by 2 is equal to, here A means BC combination came now, here B means, what combination do you get? S minus A, S minus C. By AC you will get. Right. In the next step, sin C by 2 is equal to square root of S minus A, S minus B by AB you will get. Okay. So we have got sin A by 2, sin B by 2, sin C by 2. So these are the half angle formulas for sine. Those are sin A by 2, sin B by 2, sin C by 2. Now let us go to half angles of cosine. Half angles of cosine. However, we proved half angles of sine. In the same manner, we prove half angles of cosine. See, for that I consider this submultiples formula. 1 plus cos A can be written as 2 cos square A by 2. Okay, right. Now 2 cos square A by 2 is equal to 1 plus cos A. Now transfer 2 to the right side so that you will get here cos square A by 2 is equal to 1 plus cos A by 2. Now write 1 by 2 outside, 1 plus cos A. So cos A formula B square plus C square minus A square by 2BC. Okay, now take cross multiplication. 1 by 2, 1 by 2. So when you take cross multiplication, 2BC plus B square plus C square minus A square by 2BC. Okay, right. Now in the next step, cos square A by 2 is equal to 2 2s are 4. 1 by 4. Otherwise, students, write 4 here itself, 4BC. Now observe the numerator. Here b square plus c square plus 2bc. This part can be expressed as b plus c whole square minus a square. Okay, right. In the next step, students, see here. Cos square a by 2, which is equal to, here a square minus b square can be written as a plus b into a minus b. Now a plus b plus c into, so here what do we get? B plus c minus a you will get. See here a square minus b square can be written as a plus b into a minus b by 4bc. You know, a plus b plus c is nothing but perimeter of a triangle, that is 2s. And as you know, here what can you do here? Add plus a minus a, so that you will get a plus b plus c minus 2a. No? Here what did I do? Here if you take a minus 2a, you will get minus a. Here b plus c. B plus c minus a, you can write like that. Am I right? So in the next step, a plus b plus c is nothing but 2s minus 2a. Take 2 common. Okay na students? Right here 2s minus 2a whole by 4bc. Now take here 2 common. When it is going out, it will be going to multiply with 2. 2 2s are 4. Now 4 into s into s minus a whole by 4bc. Now this 4 gone. Now what is left? S into s minus a by bc. Now transfer square to the right side. Transfer square to the right side. When you transfer square to the right side, now cos a by 2 is equal to, so square root of s into s minus a by bc you will get. So this is our required cosine angle for a by 2. Okay, half angle of cosine. So cos a by 2 is equal to square root of s into s minus a by bc. So here a, angle a, but here a, here bc you got. Similarly, can you able to write cos b by 2, cos c by 2? See, cos b by 2, what do you get? By this you can write cos b by 2. So here a came now, s into s minus b you will get. So here bc, here a, here you got bc no, here b. So except to b, what do you get here? A and c combination you will come. Okay, you will get here a and c combination. Here a, bc combination came no, here b, ac combination. Similarly, cos c by 2 is equal to, can you expect what do we get here? S into s minus c by ab. So these are the 3 required cosine angles for half angles of this triangle ABC. What are these 3? Half angles of cosine. You can say like this. Half angles of cosine. Cos a by 2 is equal to square root of s into s minus a by bc. Cos b by 2 is equal to square root of s into s minus b by ac. Cos c by 2 is equal to square root of s into s minus c by ab. Okay, I hope you have understood this half angles of sine and cosine. From this you will get half angles of tan and cot. See, half angles of tan a by 2. How do we write? Sin a by 2 by, sin a by 2 by cos a by 2. Just now we wrote sin a by 2 formula. So we got like this, s minus b, s minus c by bc. So cos a by 2, you got s into s minus a by bc. Now root a by root b. You can write root a by b. This bc get cancelled. Now this is the formula, s minus b, s minus c by s into s minus a. So you can do some more transformations from this. So this is one of the formula, and 2 more formulas you can able to write for this. How those 2 formulas will come, now I explain you. So to transform this one into other form, I would like to multiply numerator and denominator with s into s minus a. So in the denominator plus, what do you get? S into S minus A, S into S minus A. So it can be written as, so in the denominator S into S minus A, S into S minus A. Down, what do you get, amma? Root A, S into S minus A, root S into S minus A is equal to S into S minus A you will get. In the numerator, S into S minus A, S minus B, S minus C is nothing but a delta, area of a triangle. So you know that delta, area of a triangle. Okay, formula is square root of S into S minus A, S minus B, S minus C. You know that is a famous formula which was given by Heron's. So on behalf of his name, you can also call it as Heron's formula. Okay, delta by S into S minus A. Tan A by 2 is equal to delta by S into S minus A. Otherwise, square root of S minus B, S minus C by S into S minus A. Okay, now students. Right. So similarly, can you able to write tan B by 2? Okay, before going to that, you can transform into one more form also, this one. See here, for that what I am doing. To get the delta by S into S minus A, what did I do here? Numerator and denominator I multiplied with S into S minus A, no? Now I am multiplying numerator and denominator with S minus B into S minus C, S minus B into S minus C. If you multiply like this, what do you get, students? Tell me. So numerator here, like terms no, like terms no, so that you will get S minus B into S minus C. In the down, delta. This is one more formula for tan A by 2. Three formulas I wrote. First one is square root of S minus B, S minus C by S into S minus A. Second one, delta by S into S minus A. Third one, S minus B, S minus C by delta. Okay, na? Similarly, can you able to write tan B by 2, tan C by 2 formulas? You can. Now write all the possible formulas of tan A by 2. Tan A by 2 can be written as square root of S minus B into S minus C by S into S minus A. And two more formulas you got, delta by S into S minus A. Next, S minus B, S minus C by delta. Similarly, you can write tan B by 2, tan C by 2. Can you write? Write yourself. Tan B by 2, what do you get? Square root of here. A means BC combination you got in the numerator. Otherwise, write here. Tan B by 2 is equal to root of S minus A, S minus C by, so S into S minus B you will get. Okay, right. Next, tell me students, right there, delta by, what do you get in this case? Delta by S into S minus B. Now here, S minus A into S minus C by delta. Similarly, tan C by 2. Square root of S minus A, S minus B by S into S minus C. Now here delta by S into S minus C. Here, so S minus A, S minus B by delta. These are our required formulas for tan A by 2, tan B by 2, tan C by 2. Similarly, for cot A by 2, what do you do? Cot A by 2. Cot is the reciprocal of tan, no? So to write cot A by 2, cot B by 2, cot C by 2, just you have to take the reverse, means reciprocals of these three. Okay, now write cot A by 2, cot B by 2, cot C by 2 formulas. Tell me. So cot A by 2 is equal to square root of S into S minus A by S minus B into S minus C, and S into S minus A by delta, and delta by S minus B, S minus C. Similarly, cot B by 2 is equal to square root of S into S minus B by S minus A, S minus C is equal to S into S minus B by delta. Okay, students, by delta by, so S minus A, S minus C. Okay, students, similarly cot C by 2. square root of s into s minus c by, so s minus a into s minus b. Now which is equal to s into s minus c, s minus c by delta. Now which is equal to delta by s minus a into s minus b. Okay, how we have written this cot a by 2, cot b by 2, cot c by 2 by half angles of tan. Just if you take the reciprocals of those three, you will generate this cot a by 2, cot b by 2, cot c by 2 formulas. Okay, so this is the half angles of sine, cosine, tan, cot concept. Okay, now let us go to the area of a triangle ABC. To find the area of a triangle ABC, we have many more formulas, you know. So now let us go to discuss some useful formulas to find area of a triangle ABC. Area of a triangle ABC. You know, name of the triangle is ABC. So you know, BC length is denoted by small a, AC length is small b, AB length is small c. Now drop an altitude from A to BC, which meets opposite side, that is D. Okay. Now to here, you know, delta represents what? Area of this triangle ABC. Now we have to read this delta, which is equal to 1 by 2. This is base. Base is how much? Small a. Now height is AD. Students, you know, to find the area of a triangle, we use 1 by 2 base into height, no? So I applied this formula. Okay, now go to this BDA triangle. You know, AD is an altitude means which makes 90 degrees with opposite side. And define sine B. Now sine B is equal to how much in this triangle? So opposite is AD by hypotenuse is small c. Now AD is equal to C into sine B. Now AD is equal to, what do you write? 1 by 2 small a into C into sine B. So 1 by 2 AC sine B is one of the formula to find area of this triangle ABC. AC, here this is A, this is C, and this is included side angle of A side, C side, means BC side, AB side. A represents length of BC, C represents length of AB. So what is the included angle of these two sides? B. Now here 1 by 2 product of adjacent sides. A and C are adjacent sides, lengths, no? 1 by 2 product of adjacent sides and sine of included angle. Okay now. Similarly you can write, if you take these two sides as adjacent sides, and this will be the included angle, no? 1 by 2 product of adjacent sides and sine of included angle. Similarly, delta is equal to 1 by 2 if you take these two sides as adjacent sides BC into sine of included angle, sine A. Now we have written three formulas for area of the triangle ABC. Okay na students? Note down these three. Right. See, if you take any one of the previous three formulas, like delta equal to 1 by 2, AB. Okay, for A and B, okay, included angle is C, no? 1 by 2 AB sine C. So, you know, here sine C, take the sine rule. C by sine C equal to 2 or no? Now make sine C subject. If you make sine C subject, C by 2 r you will get. Now come here. Now delta is equal to here 1 by 2 AB into sine C. Sine C can be written as C by 2r. Now delta is equal to ABC by 2r. This is also one of the formula to find area of the triangle ABC by 2r, where ABC represents the length of sides of a triangle, r represents circumradius of triangle ABC. Okay, students? Right. Next, students, see here. Okay. See this sine A. Write half angles of sine A means write whose submultiples formula. You get 2 sine A by 2 into cos A by 2, no? Right. 2 into, write sine A by 2 formula. Sine A by 2, half angle of sine you learnt as s minus b into s minus c by bc. And cos A by 2, square root of s into s minus a by bc, no? Now, okay, simplify. Here root bc into root bc, bc. Here numerator 2. So here what is left? Root a into root b, root of s into s minus a, s minus b, s minus c. Okay, what do you get, students? You can write like this. S into s minus a, s minus b, s minus c. This is one of the formula for sin A. Sin A is equal to 2 by BC, root of this you will get. Okay, now students. This is nothing but delta. Okay, now 2 delta by BC also you can write. 2 delta by BC also you can write. Okay, students. Similarly, can you write sin B, sin C? Yes. Sin B. Sin A means here 2 by BC you got. So here sin B means 2 by AC you will get. Here A, BC combination came. Here B, AC combination will come. Here no changes. Same you will get. S minus B, S minus A, S minus B, S minus C you will get. Okay, students. Right. Similarly, can you write sin C? Sin C is equal to 2 by AB root of S into S minus A, S minus B, S minus C. So these are some useful formulas. Okay, sin A, sin B, sin C. So which helps you while doing the applications. Okay, so this is my first part. Okay, from this properties of triangles. So in the next 2 classes, okay, I will explain you the rest of the properties of triangles chapter. I hope you have understood this class. So I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Thank you, students. Thank you.